right, today we are talking about 10-2, measuring angles and arcs. So the first thing here is a central angle. A central angle is an angle with the vertex at the center of the circle. So if we have a circle, that won't work. If we have a circle, and the center of the circle, then this would be a central angle because it's an angle that's formed with the vertex at the center. The sum of the central angles, I think this is something you probably already know. The sum of the central angles of a circle with no interior points in common is 360. So in the example on the side there, angles 1 plus 2 plus 3 is 360. You can kind of think about that as the degrees around a circle, which again I think you already know is 360, or that if this were a straight line across in the circle, that'd be a diameter, right? It'd be 180 on each side of that, given that it's a straight angle. An arc is a portion of a circle defined by two endpoints. So if we have a circle, then an arc is just a portion of that circle. And we usually have names, so we might call it AB. And we would write it like this, arc AB. So here, before you go in and write everything, for the first box, having minor arc, and then, or just the part here, the measure of a minor arc is less than 180 and equal to the measure of its related central angle. We do measure of arc AB is the same as the measure of angle ACB. So its central angle ACB is the same as the measure of this arc. The same kind of thing for these other ones. The measure of the major arc is greater than 180 and equal to 360 minus the measure of the minor arc with the same endpoints. And then the measure of a semicircle is 180. Again, as I kind of mentioned on the last slide, the line there, the segment that makes the semicircle is AB here, which is a diameter, right? So, sorry, the pause was there for you to try to answer or think about it, not because I forgot. Congruent arcs are arcs in the same or congruent circles that have the same measures. That should not be surprising. That's what congruent means. In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So giving a more direct reasoning here. So if FG, if angle 1 were, 80 degrees, then from the last slide, we know that FG must be 80 degrees as well. If angle 2 were 80 degrees, arc JH would be 80 degrees, and then the two arcs are the same, so they are congruent as well. It would work the exact same way going the other way. Adjacent arcs are arcs in a circle with exactly one point in common. So if we have our circle, and we have one arc, and they meet right here, and we have our second arc, A, B, C. We could say that arc AB is adjacent to BC, arc BC. We would not, however, say arc AC is not adjacent. If I messed up saying that, this is we would not say they are adjacent. So arc AC and AB are not adjacent because they share all of arc AB in common, right? Arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Think that we had two postulates, angle addition and segment addition, that are basically the same thing as this, just that this is on the circle. So if we know what xz, sorry, if we know what xy and what yz are, to find xz, we're just adding the two together. We can do an example. If yx were 20 and yz were 25, then xyz is 45. Arc length is different than arc measure. Arc measure is given in degrees. Two different sized circles could have the same arc measure for different segments or different arcs. However, arc length is the distance between the endpoints along an arc measure in linear units. So this is going to be in units, feet, meters, things like that. This is based on the circumference and then how much of the circle it is, right? So if we know the arc measure and we know the circumference, we should be able to find the measure of each arc, or its length. And that is found here. This is extremely important to be able to get this. I like the proportion. I like this one. You might like the equation better. That's okay, use the equation. I like the proportion better because sometimes we solve for x, sometimes we solve for r. And the equation more or less is just solving for arc length, where, like I said, our problems can make us do many, many different things. With that, notice that this is a proportion. The proportion here is the arc length, L, the arc length, over 2 pi r. Well, 2 pi r is something for us, right? So think about what 2 pi r is, and hopefully you can come up with that is the circumference. So we have the length of the arc over the entire circumference, right? We have a length of the part over the length of the whole, or the distance of the part over the distance of the whole, right? And then the second part, x over 360. X is the central angle measure, right, over, well, the sum of the central angles, 360. So it's part over the whole. So we have the part, the length of the arc over the circumference equals the part of the central angle over all of the central angles. All right? And then it's a proportion. We've been dealing with proportions for quite a while. Hopefully you can tell where the equation comes from, though, again, I personally like the proportion better because it's a little bit easier to solve for x and r through it. All right, I'm sorry that my circle does not look like a circle here. I actually didn't draw it. It's just the way that it expanded. We are told that PR and QT are diameters of circle A. Again, remember it's called circle A because A is the center. PR and QT are diameters. That means that they are chords of the circle that go through the center, right? Diameter is a chord that goes through the center. It's made up of 2 radii, right? Identify each arc as a major arc, a minor arc, or a semicircle of the circle, and then find each measure. For some of these, or maybe all of them, we might find the measure first and then decide whether it's a major arc, minor arc, or semicircle. I would say the hardest part here is remembering that major, minor, and semicircle do not go or do not have the same measure values as like acute, right, and obtuse, right? Major is more than 180, not more than 90. So major, more than 180, minor, less than 180, semicircle, 180. And that will be from a diameter. So we're looking at UPQ. Haven't really talked about this yet. When it talks in the arc, just like when we talked about triangles, the order here matters. So it's telling us to go from U to P to Q, right? So U, P, then Q is arc UPQ. So that order matters. You cannot go UQP, right? UQP would be this arc, right? Which is a different arc. So we want this one. And we have our right angle here. Since the central angle here is 40, that arc is 40. That arc is 90. So the measure, the arc measure is 130. And that is a minor arc, right? Again, minor goes until 180. If you didn't get a chance to draw the diagram, you might pause the video to do that, so that you're not trying to do 3 things at once. PQR, again, goes in order. We start at P, going to Q, over to R. We notice, hopefully, that it is this here, PR, is a chord that goes through the center, making it a diameter, which means automatically PQR must be 180 degrees. If you couldn't figure that out, right, we have a 90-degree angle here on a straight line. The other angle must be 90. I think it's 180. This is a semicircle. At any point, if you think that you've got it, you might pause the video and come back. At least for 5 and 6, when we get down there before we start number 5, you should do that. UTS, again, order matters. It is UTS, not UST. And this one might take a little bit more work, but not a lot. We have a 90-degree angle here. We have a 40-degree angle here. And then we have a straight line. That straight line has to have 180 degrees. Minus the 90 gets us down to 90, minus 40 gets us to 50. So that angle is 50 degrees. And then we're actually coming back and adding 40, 50, and 50. We should get 140, which is a minor arc. RS. Here, so that it's not confusing at all, you might ask yourself, well, there's only 2 letters. Which way do I go? Do I go the long way around or the short way around? For a major arc, it has to have 3 parts. So a measure of an arc, RS, cannot be or should not be a major arc. It should only be a minor arc. I believe they usually don't write semicircles with only 2 letters as well. So it has to be the minor arc. That's 50. Again, it is minor. again, pause, take a look at it, and then come back to it. I'm going to keep going though. We have PQS. We have 90 plus 90 plus 50, which is 180, which is 230. That's more than 180, so it is major. And then PRU, we're going to do this one the other way. It's fine if you added them all up, but it is actually 360, all the degrees around the circle, minus 40, that central angle that's left, which is 320, and this is also major. Use circle D to find the length of each arc, round to the nearest hundredth. So we have, we're looking for the measure of arc KL if JD is 7. JD is our radius. It's 7. We're looking for KL. That means all of the radii are 7. It doesn't matter which one we look at. We should notice that we have a central angle of 60. We should be able to find the circumference. So we have the arc length over 2 times pi times r, again r is 7, equals the central angle 60 over 360. If you want to simplify, you can. So we would get 1 over 6 here, and then when we cross multiply, we get 6 times the arc length equals 14 pi. Divide both sides by 6. And our arc length is 14 pi divided by 6, about 7.33 centimeters. All right. Number 8, we're looking for NJK. NJK. The radius, it does not give us the radius here, it gives us the diameter, right? The radius is actually 6. The diameter is 12 because NL is the diameter. And then we do need to find what this central angle NDJ is, right? And we see that we have a straight line here with measures of 50 and 60. 50 and 60 add to 110, leaving us with 70 so that we can get to 180. And so the arc there is 70 plus 50, which is 120. So we have the arc length over 2 times 6 pi, right? 6 again is the radius, equals the arc measure, or the central angle measure, which is 120 over 360. That simplifies to 1/3. So we get 3L equals 12 pi, or L equals 4 pi. And L is about 12.57 feet. All right, I want you to pause the video, try to do the next 2 on your own, and when you come back, they will be completed. I'll talk about them a little bit if I need to. All right, I have those 2 answers up. Don't think that anything was significantly difficult about them. I guess in your homework problems, Make sure that you do find, like in number 8, whether it's the radius or the diameter. I believe in the homework they may ask questions like giving you the arc length, asking you to find the radius. You would solve it the same way, just a different variable. But otherwise, it should be pretty much the same. And yeah, I think that's it. The bigger concept to understand here, again, is kind of similar to what we've been working on with proportions. It's arc length, which is a part of the circle over the whole circle. We have the arc measure, which is a part of a circle over 360, the whole circle. So it's part over whole, which fits kind of like how we've been talking this whole year with the proportions and the stuff that we've done. Oh no, that's not what I want. There it is. All right, homework, page 710, numbers 12 to 20 even, 36, 38, and 45 to 47. I do plan to be on Zoom again. There will be a link for that in the instructions page for today. And this again, this page 710 will be due tomorrow. Hopefully we're getting in the one that was due today by noon. It looked like a number of you already got it in. So far, very happy. I think only maybe one honor students out of all of the 42 of you that I have didn't do the discussion post yesterday. So very, very happy with that.